Hi everyone, in this video we are going to learn more details about the dipole-dipole interaction and an extreme example of the dipole-dipole interaction known as the hydrogen bond. So the dipole-dipole interaction depends on the dipole moment of the two polar components, and they must be polar in order to have a dipole moment. So the dipole-dipole interaction will not exist for nonpolar molecules. And this is even more sensitive to distance. It's proportional to 1 over d cubed. So take, for example, that ion-ion interaction where we saw it was proportional to 1 over d. So if we take those ions and separated them by twice the distance, the electrostatic potential energy increases twofold. But if we do the same thing for the dipole-dipole interaction, we pull those molecules further apart by twice the distance, that is an 8-fold increase in the electrostatic potential energy. So a huge difference there with respect to the effect of distance on the electrostatic potential energy and the strength of this intermolecular force. So the dipole-dipole is a directional force. So HCl, for example, has a dipole moment like this and will align with other HCl molecules such that the dipoles, the opposite end of the dipoles, match up. So the negative end of my dipole with the positive end of my other dipole. And this is just one example of a way that these dipoles can align. We can also have HCl aligning kind of side by side here, where we have delta plus and delta minus, and then we'd have ClH aligning like this, where we have delta plus and delta minus. So there's the attraction in that way as well. And there are essentially an infinite number of ways that these molecules can align, and then the total dipole-dipole interaction is the average of all of these possible interactions. And overall, the dipole-dipole interaction is weak compared to the others that we've looked at so far. And this is on the order of about 0.2 kilojoules per mole. Comparing that to the energy to break a bond is on the order of like 400 kilojoules per mole. So there's a huge difference in the terms of the strength of the intermolecular force compared to the strength of a covalent bond. Thanks for watching.